Alright, good evening, or afternoon, or morning, whenever you're watching this video. Um, we are now... Hang on. There's an interruption for pictures. Okay, freshmen. You guys aren't freshmen, this doesn't matter. So, alright, so we're finding empirical formulas here. This you knew how to do last year, or 2 years ago if you haven't taken chemistry in a little while. It's just going to take a little refresher here to remember exactly how this works, but I think you'll get it. Those of you who had me last year, and I don't think I put this in the PowerPoint, but I like this little flow chart. That's kind of nice. Given the mass percentage, you assume a 100 gram sample. That gets you to grams. You use the molar mass to get to moles. You calculate the mole ratio to find the empirical formula. Okay? Or you can remember my poem, which is written on your paper. Percent to mass, mass to mole, divide by small, multiply till whole. Okay, and that basically says the same thing. It doesn't exactly say how to get there. You have to remember that part. But your first step is going from percent to mass, okay? And that's when you assume a 100 gram sample. So basically, if you have 55%, it's 55 grams, okay? You just assume you have a 100 gram sample. Mass to mole is this part, and you use the molar mass to get there, okay? Divide by small is how you calculate the mole ratio, okay? Well, actually, and I should say this, there's one step that they really didn't put in here. So the divide by small part is here. And then sometimes you're going to have to multiply till whole. In other words, if you don't have a whole number when you divide by the smallest one, this is going to make sense after we go over the examples, I think. But that's how you get to the empirical formula, okay? And it's really not a hard process. They have a certain type of problem in here that kind of is a little bit more difficult. But here's how this works. And actually, I think I'm going to show this to you on the handout that you have because it's more step-by-step on there. So let's see if we come down to this. So the compound para-aminobenzoic acid, PABA, P-A-B-A, it tells the percent composition of that. We've got 4 things in there. We've got carbon, hydrogen, nitrogen, and oxygen. And we want to know the empirical formula of it. Okay? So it's giving us percentages here. So the first part we have to do is the percent to mass part. Okay? If we assume 100 gram sample, that's pretty easy. That means that we have 61.31 grams of carbon, 5.14 grams of hydrogen, 10.21 grams of nitrogen, and 23.33 grams of oxygen. Okay? So you just change the percentage to gram. That's all you have to do on that part. Okay? Now the mass to mole part, what we have to do is convert each of these into the number of moles that they have. So we've got 61, this is interesting how it's writing in Word, 61.31 grams of hydrogen. We've got 5.14 grams of nitrogen. No, I'm getting that wrong, sorry. That is, what's going on here? This is strange. Never done this before. Okay, so we've got 61.31 grams of carbon, 5.14 grams of hydrogen. See if I can fit all these. 10.21 grams of nitrogen, and 23.33 grams of oxygen. Okay, so those are our 4 things that we have. We have to change all of these to moles. So what you have to do there is use the molar mass. So you go from grams of carbon to moles of carbon. In 1 mole, there are about 12 grams. I'm being a little bit lazy here. You can look on your periodic table and get a little more exact if you want to. This will usually work out okay. Grams of hydrogen over moles of hydrogen, or under moles of hydrogen. And that's about a 1-to-1. For nitrogen, running out of room here. It's about 14 grams of nitrogen in 1 mole. And for the oxygen, it's 16 grams in 1 mole. Okay? So that's going to give us the number of moles of each of these. And once we do this, it's going to give us about 5.11 moles of oxygen. No, carbon, sorry. It's going to give us 5.14 moles of hydrogen. That's not right. 10.21 divided by 14. It's going to give us about 0.729 moles of nitrogen. And a lot of times, if you don't round quite as early on these, then you'll get better numbers. It just sort of depends. And then 1.45 or 1.46 moles of oxygen. Okay, so that's our number of moles that we have. Now, the divide by small part, that's the next part. You can go ahead and rewrite these numbers here. See, this one was 5.11. Okay, so we got 5.11 moles of carbon. We've got 5.14 moles of hydrogen. We've got 0.729 moles of nitrogen. And we got 1.46 moles of oxygen. Okay? And basically what we want to do here is divide by the smallest number. Okay, divide by small. So the smallest number we have on here is the 0.729. We're going to divide everything by 0.729. And see what we come out with here. And obviously for the nitrogen, it's going to be 1. For the carbon, it's about 7. It's going to be about the same for hydrogen, I'm guessing, because that's pretty close to the same number. Yeah, about 7. And the oxygen is going to be about 2. Okay, so those numbers work out pretty nice. We don't have to worry about the multiply till whole part. Okay, but what that's giving us there, that's giving us the mole ratio of these things in a compound. Okay, so again, in this example, we don't have to multiply till whole. So what this is telling us is these are the subscripts for our empirical formula. And it doesn't necessarily matter right now what order you write these in. Usually in an organic compound, we're going to write the carbon and the hydrogen first, nitrogen and oxygen at the end. So probably the way I would write this would be C7, H7, NO2. Okay? So that's going to be your empirical formula on that one. All right. Let's keep moving on here. So hopefully that makes sense, and hopefully that's coming back to you. Another sample problem here. Ascorbic acid is vitamin C, and it gives you the percentages of carbon, hydrogen, and oxygen, and they want to know the empirical formula. Okay. So again, now we're just putting it all together instead of doing it step by step. And this, I think, is going to be fairly easy for you. All you have to do is change these to masses from the percent, 40.92 grams of carbon, 4.58 grams of hydrogen, and 54.50 grams of oxygen. Okay? So we're converting these and again, we're just using our same molar masses we used before. I like carbon, hydrogen, and oxygen. They're easy. And a lot of times these empirical formula analyses will involve those. So it's going to give us 3.41 moles here. It's going to give us 4.58 moles here. And that's going to give us 3.41 moles here. Okay. The smallest one is 3.41, and that's actually two of them are 3.41, so that's kind of nice. So we'll divide by the smallest one here. see what we come up with. This is going to be 1. This is going to be 1. And we take the 4.58 divided by 3.41. Okay, well that's an interesting number. It's about 1.3, which you're going to get that sometimes when you do these. You might get 1.3, you might get 1.6. There are certain other numbers that you might get, decimal numbers that you might get that are, they're not whole numbers, okay? And so what we have to do here is that last step, which is called multiply till whole. And all you have to do there is you have to multiply all of these by some common factor, or some common multiply, I guess, that would make all of them be whole numbers. So this is 1.3 for the moles of hydrogen, okay? So if we multiply all of these by 3, now I rounded here, this is about 1.34 actually, so if we multiply all of these by 3, that's going to get us pretty close to whole numbers, okay? So this is going to be 3, this is going to be, what, 4, and this is going to be 3. So that gets us to whole numbers, and then all we have to do is write the actual empirical formula, okay? So the empirical formula is going to be C3H4O3, okay? Hopefully that makes sense. I don't think that's too difficult. Now let's say that we're wanting to calculate a molecular formula from the empirical formula. Okay, so molecular formula from empirical formula. We've got a sample problem here. Oops, forgot to put subscripts on that one. It has an empirical formula C3H4. The experimentally determined molecular weight of this substance is 121 AMU, which 121 AMU, if you remember, is also 121 grams per mole, okay? The two units are kind of interchangeable with the numbers. And they want to know what the molecular formula is. Now this one's nice and easy because they've already given you the empirical formula. A lot of times on these molecular formula problems, you'll have to find the empirical formula first. But since we've done that a couple of times already, I didn't think that we need another example of that. So they're giving you the empirical formula here, C3H4. Okay? And then they're also giving you the molar mass of this substance is 121 grams per mole, okay, of the actual molecular compound. Now, what we have to do here is we have to remember the difference between empirical and molecular formulas, okay? Empirical is the simplest whole number ratio. And then molecular is just the actual formula, or the actual ratio in the compound. Okay? Now, the molecular formula could be the same as the empirical formula. Because, for example, H2O, okay, that is a molecular compound, okay, or molecular formula, because that is actually the formula for water. There are 2 hydrogens for every 1 oxygen in water. But it's also an empirical formula because you can't reduce that any further. That is the simplest whole number ratio of those 2 things, okay? But something like H2O2, that is a molecular formula, but it's not an empirical formula, right? Because that's the actual ratio. There are 2 hydrogens and 2 oxygens there. But if you were going to reduce that, it would be HO. That would be the empirical formula, okay? So that's an example of one that's a molecular formula, but not empirical. So that's the idea there, okay? Now, the way that we figure this out is we find the molar mass of the empirical formula. Okay, so they gave us this empirical formula, C3H4. The molar mass of that, again, I'm being a little bit approximate here, is going to be about 40 grams per mole. Okay? The molecular weight, or the molar mass of the actual compound, now remember, this is not the actual compound, that's just the simplest whole number ratio. Okay? The actual compound is going to be 121 grams per mole. So you can probably already tell where this is going. it looks like the actual compound, well, here I should have drawn the arrow the other way. It's about 3 times larger than our empirical formula, okay? So that means we need to multiply our empirical formula by 3. C3H4, if we multiply that whole thing times 3, that's going to give us the actual molecular formula, okay? Which is going to be C9H12, okay? And if you want to double check just to make sure, if you find the molar mass of that, 12 times 9, carbon is about 12 times 9 for 9 carbons, plus 12, that gives you about 120, 121 grams per mole, okay? So this is our molecular formula. Okay, I'm going to stop there. On the next video, we'll talk a little bit about a special type of empirical formula that you might have to find. I just want to make sure this video doesn't get too long.